Section 2.2 is on page 41. So I'm going to do 2.2 with 1.2 before I do 1.3 because it's a bit longer. And next week I'll do 1.3 with 2.3 as one lecture. And 3.2 is on its own because that's a bit lengthy. 2.2 on page 41 talks about separable equations, and what separable equations are pretty much the calculus that you learned in your 1150 class or second semester calculus. So we say dy dt equal ay plus b, or dy dx equals f of xy is a separable equation, if it can be written in the form n of x times dx plus m of y dy. Basically, I could separate the x and the y, so a function of x dx, a function of y dy, or I could write dy dx as a function of x multiplied by a function of y, in which I could separate those and integrate it traditionally like I would do in calculus. So let me get some problems. And I'd like to look at the following three problems really quick. They're asking on the following: determine whether the given differentiable equations are separable. So the reason you want to separate, if you could separate the dy with the y and the dx with the x, then you could integrate like you did in calculus. If I cross multiply, wouldn't you say dy divided by 4x squared for y squared minus 3y plus 1 equal dx? Since you were able to separate the y with the dy and the x with the dx, you would say yes, this is separable. If I integrate, of course this requires integration, a partial fraction, but I can integrate it. So here you're just trying to figure out, can I separate those or not? If I look at number 4, I could say, well, this is y. Isn't that e to the x times e to the y over x squared plus 2? Can't I say dy is y e to the y times e to the x over x squared plus 2 dx? And wouldn't you agree that dy divided by y e to the y equal e to the x over x squared plus 2 dx? So since I was able to separate the x with the dx and the y with the dy, I will say yes, this is separable. I get to number 6, say okay, well let's see how that works. Let's move that over. ds over dt equal s. So there is no formula of figuring this out. And here I will have a heck of a time separating the t from the s because of that s squared. If I say let's get a common denominator, I just made the problem worse. How am I going to be able to separate? If they're multiplied, I could separate them easily. But if they're added or subtracted, there's no way of doing that. And in calculus, we dealt with all the separable equations. I'd like to look at the following next 3 problems. Number 10, solve each equation. Well, if I cross multiply by dx and get the y squared on the left, that would be y squared dy equaling x over the square root of 1 plus x dx. And if I integrate, this would be y cubed divided by 3 equal, and here we have a problem. I need to get rid of a radical. We know how to do that. Let u equal the square root of 1 plus x, right? U squared would be 1 plus x So u squared minus 1 equal x, and dx would be 2u du. So that will be the integral of 2u du, that's this. I should have gave it a bit more space. 2u du, that would be this. This is right there, and x is actually u squared minus 1. So those u's cancel out. I'm getting y cubed divided by 3 equals twice the integral of u squared minus 1 du. I'm getting y cubed over 3 equaling twice. Wouldn't that be u cubed over 3 minus u plus c? What's u? U is the square root of 1 plus x. And I could say y equals 6. Actually here, let me simplify one more, that's okay. Y cubed over 3 equals twice the square root of 1 plus x cubed over 3 minus twice 1 plus x plus c. And I could say y equal, if I am to multiply by 3, I will get twice the square root of 1 plus x cubed minus 6 into 1 plus x plus c. And if I cube root both sides, that would be my final answer. So techniques of integration is a must in this class. And luckily we just finished math 1150. If I look at the next problem, same deal. Well, I'll say dx dt equals x cubed plus x. Dx equals x cubed plus x dt. So dx divided by x cubed plus x equals dt. And if I integrate, I'm looking at the integral of dx over x into x squared plus 1 equals, this is t plus c, that's not a problem. I'm going to go on the side and figure out what this is. 1 over x into x squared plus 1 equals a over x plus bx plus c over x squared plus 1. If I clear the fractions, that's how you do this. And if I multiply by x, and here at this stage I could figure out automatically what a equal. If I let x equal 0, I'll get 1 equal a times 1, and this will be a 0, so a is 1. That's going to make my life a lot easier. Now if I follow the Hooke's method, that's x squared plus 1 plus bx squared plus cx. If I get that x squared, the x and the numbers, so this says 1 plus b equal a 0, that means b is negative 1. C, there is no x, c is 0, and I already know what a is. So this is a negative 1 and this is a 0. This tells me this is the integral of 1 over x minus x over x squared plus 1 dx equals t plus c, natural log of x minus, if you let u equal x squared plus 1, du will be 1/2. So that's 1/2 natural log of x squared plus 1 equal t plus c. And since I can't solve this equation for x, you could leave the answer like that. You could combine those and play with it, but it's going to be very hard to solve for x. That's not a problem. That would be the answer for this problem. And if I look at the last, number 16, let me think really quick. Do I need, probably I'm going to need a lot more space than this. Not a problem. Let me move number 16 down. And let me move this. Okay. You know what? Okay, and here we are looking at number 16, and 16 has dy over y equals y e to the cosine of x sine of x dx with a negative. So I have dy over y squared equaling e to the cosine of x sine of x dx. And if I integrate, I'm looking at, this is y to the negative 2, add 1 to the power, divide by that, negative 1 over y equals, here if I let u equal the cosine of x, du is negative the sine of x dx, so that picks a negative e to the u du. So that becomes negative e to the u plus c, negative 1 over y equals negative e, and u was a cosine of x. So 1 over y, if I take the reciprocal of this side, that would be the reciprocal of this side. That's the first set of problems. The next set of problems, they give you the initial condition, meaning you could actually find the value of c. Let me get those going. And here's a problem. Solve the initial value problem. Well, I noticed that this is dy dx equaling x cubed into 1 minus y, or dy over 1 minus y equal x cubed dx. If I integrate, I'm looking at negative natural log of 1 minus y equaling x to the 4th over 4 plus c. And if I change the signs, I'll get 1 minus y to equal e to the negative x to the 4th over 4 plus c, which is really e to the negative x to the 4th over 4 times e to the c, something you should get used to. And if I swap those, I'll get 1 minus e to the negative x to the 4th over 4 times e to the c equal y, except I should find what c is. So if I replace x by a 0, I'll get the y to be a 3, which indicates that 1 minus e to the c equal 3. So e to the c will equal 1 minus 3. E to the c is actually a negative 2. So I would say y equal 1 minus 2. Oh, negative times a negative is a positive 2. E to the negative x to the 4th over 4. That would be my solution to this initial value problem. Okay, the next problem up is number 20. And I'm glancing at this problem, trying to figure out how to do this. Well, it is separable. That is, if I cross multiply by x squared, by dx, I'm looking at 4x squared minus x minus 2, and an x plus 1. And if I divide by this x squared, that will be right there. And if I multiply by y plus 1, there it is. And now if I integrate, the left side is simply y squared over 2 plus y. That's not that big of a deal. The left is a different story. Partial fraction decomposition again. That happens a lot. So if I take 4x squared minus x minus 2 divided by x squared into x plus 1, that is a over x plus b over x squared. plus c over x plus 1. If I clear the fractions, again, like I mentioned, if you look at the YouTube videos, you'll notice tons of examples from the other class that I have, calculus. It's called Math 5B. And here, I talk about that trick in that class. If I let x equal 0, that's a 0, that's a 0, that's a negative 2. A 0 there, that's gone. A 0 there, that's gone. A 0 there, that's simply b. How do you like that? And if you let x equal negative 1, basically the domain. A negative 1 there, that will make that a 4. Negative, a negative 1 is plus 1 minus 2. So that is 4 plus 1, 5 minus 2, which is 3. A negative 1 here will make that a 0. A negative 1 here will make that a 0. A negative 1 there will make that a c. What do you know? And if I let x equal any other value than 0 or negative 1, let's say 1. 4 minus 1 minus 2. 4 minus 1 minus 2 is 1. A 1 in there, that is a times 1. And 1 plus 1 is a 2. A 1 right there, that is b, but I know b is negative 2. And if I put a 1 there, that's a 2 as well. And c I know is a 3 times 1 squared. And there I can figure out what a is. 1 equal 2a minus 4 plus 3. 1 equal 2a minus 1. So 2a equal 2, a equal 1. So I got this to equal 1 over x minus 2 over x squared plus 3 over x plus 1. Integral, I didn't integrate yet. I just integrated the left side. So y squared over 2 plus y equals natural log of x minus plus 2 over x plus 3 natural log of x plus 1 plus c. I need to solve for y if I can, and here I can. If I multiply by 2, I'll get y squared plus 2y equaling twice natural log of x plus 4 over x plus 6 natural log of x plus 1 plus c. Oh, I forgot about the initial condition. So if I take, in this case, if I replace a 1 for y, I'll get 1 plus 2 equal twice natural log of 1 plus 4 plus 6 natural log of 2 plus c. This is a 0. So this is 3. 3 minus 4 is negative 1. So c is negative 1 minus 6 natural log of 2. That looks awkward, but that's what it is. Whatever works. Okay, so if I complete the square, that is, if I take half of the middle number and square it and add it to both sides of the equation, I'll get y plus 1 squared equal twice natural log of absolute value of x, 4 over x, 6 natural log of x plus 1. This turns out to be very unorganized. Plus c, I got c to be, there is a plus 1. There is a minus 1. They're going to undo each other. Minus 6 natural log of 2. So if I square root both sides, and move the 1, but the initial condition is going to determine, since y of 1 is positive, since when you substitute a 1 in for y, you're going to get a positive. There's no way it could be this minus. And you could check. If you put a 1 in there, that will be twice natural log of 1, which is a 0, plus 4, plus 6 natural log of 2 minus 6 natural log of 2 minus 1. and the minus 1 is outside the radical. Those cancel each other out. That's gone. That will be square root of 4, which is 2 minus 1, which is a 1. Pretty cool, huh? And that's pretty much it. Let me give you the homework. And there's the homework on page 46. You're going to do 1 through 25 odd. This is probably the longest homework I'll ever give you. 1 through 25 odd.